We'll proceed in summation and integral calculus. Summation and integral calculus, into which we are pursuing a discussion. Summation and integral calculus. How we can divide our problem into n number of parts and solve the problem part by part and then sum it, whatever is the scenario. Okay, we were kind of trying to calculate area of a circle by dividing the circle into n different parts radially. Okay, what we were trying, if this is a circle, if this is a circle and this is x-axis, this is y-axis, this is radius, and in angular fashion, radius is moving in a circle. We are mixing two coordinate system here. One is Cartesian coordinate system. I would rather say in Cartesian coordinate system. In Cartesian coordinate system, we are trying to draw polar coordinate system. Okay, like if this is x-axis, this is y-axis. This is called rectangular coordinate system or Cartesian coordinate system. In Cartesian coordinate system, if I try to draw polar coordinate system, it will look like this. There is a radius like this and it moves in an angular manner. This is called polar coordinate system drawn in Cartesian coordinate system. Polar coordinate system itself is a different coordinate system the way Cartesian coordinate system is. So this can be, I can say, this is a polar coordinate system. This is theta and this is r. If I say that I have a circle like this and this is radius and this is angle, actually this is polar coordinate system we are trying to draw in the Cartesian coordinate system. This is Cartesian coordinate system. Inside Cartesian coordinate system, I have a circle. If I take r and theta, that is polar coordinate system, this is theta and this is r. If I take theta and r as a polar coordinate system, then this circle will be mapped like a rectangle in the r theta plane, where the relationship is x equal to r cos theta, y equal to r sin theta. Is it required that it will always be like a rectangle will map into a circle in Cartesian coordinate system? Not required. We have already given an example. Consider r equal to cos theta. Consider r equal to cos theta. In theta r plane polar coordinate system, r and theta are not making rectangle. Rather than they are making a cosine wave, r equal to cos theta or r equal to sin theta. Then there will be a graph like this. Okay, this is called r equal to cos theta. It will start from r equal to 1 and then it will go like a cosine wave. R equal to sin theta, it will start from 0 and it will go like a sine wave. Even that in Cartesian coordinate system, if I map with the relationship x equal to r cos theta, y equal to r sin theta, where r equal to cos theta, still it will form a circle. Circle will be different. Okay, this is the circle in Cartesian coordinate system where r is constant and theta is 0 to 2 pi. This is a circle in Cartesian coordinate system where r equal to cos theta, and in that manner this full angle is pi only, 180 degree, not 360 degree. Anyone can try. Now the question is arising, can I try our length vector? Okay, the question is arising, how I can use the summation to calculate the area. To calculate the area, if this is a circle, the radius would move like this and creating many sections, n number of sections when it is moving like this. This is the x-axis and this is the radius. Radius is moving like this. First section, second section, ith section. Like that, it is making n section when it is moving full round, n section. Okay, what is the area of this circle? Now find all the section area and add it. Area number 1 plus area number 2 plus area of the section 3 plus area of the section I plus area of the section n. If I add all n, I get the total area. Summation I equal to 1 to n. area of the ith section. Now dispute is happening how to calculate area of the ith section, because that has to be very generic. Then we found that if I try to find area of the ith section, then this is radius. This is radius and this is the arc that is forming the ith section. If I do cross product of this vector and this arc vector, then I'll arc vector. Then I'm sorry. If I do cross product of this length vector is a vector that represents a line or a curve. If this line has a vector representation and this arc has a vector representation, if I do cross product of these two vectors, it will give area between these two lines. Okay, can I use this concept that cross product of any two vector? This is a vector, this is a vector. Cross product of any two vector give the area in between it. That is a parallelogram. Cross product of any two vector. Okay, one vector can be an arc, can be a curve, not required a straight line. If this is the curve and this is a vector, if this is a curve and this is a straight line, if I okay, if I do cross product of this and this, then it gives the area under between it. Can I use this technology that cross product of two vectors give the area in between? Okay, then vector representation of the arc need to be found out. Then it is possible. Now we are trying to get, if I divide this circle into n part, if I divide this circle into n part, then this is the ith part. For ith part, what is the area? If I find the ith part area, then I can sum it. Summation sigma sign, summation I equal to 1 to n, area of the ith part. Can I use this technology that if I have vector representation of this line and vector representation of this curve line, if I do cross product of this, it gives the area between these two. Can I use this technology to get the area of the ith section? Okay, for that we try to find the vector representation of this. So this is radius vector. This is radius vector and this arc is more or less theta vector. Okay, anyway, the position vector, if I talk, okay, we'll proceed here. So if this is x-axis, we have already talked about it. If this is x-axis and this is y-axis, if I take any point P here, that is at radius r and angle theta, then what is point P in the polar coordinate system? One is r and another is this length, that is r theta. So this point is r comma r theta. This position vector is r unit vector plus r theta unit vector. The way if I say this point is x comma y, then this position vector will be xi plus yj. Okay, now in similar fashion, if I have a line and one point is 0 comma 0 and another point is r comma another point is r comma r theta, r comma r theta. In r theta, r is constant and theta is variable. Then what is this? What is the vector? Vector would be r unit vector plus r theta unit vector. Okay, this is a representation of a curve for a straight line. If I want the vector representation for the curve, that is a curve, not a straight line, then please watch our previous video. Then I have to take out the independent component here. If I take out independent component from here, it gives me the formula of a curve vector possible. So r unit vector plus r theta unit vector. If I'm trying to find the cross product of two vectors in the ith section of area, one vector is r. Along this vector, theta is constant. And there is another vector, that is the arc vector. Okay, so this vector is r unit vector plus r theta unit vector. I have to take out r. It will become r by r unit vector plus r theta by r theta unit vector. Okay, as per the calculus, division will become differentiation and multiplication will become integration. It will become dr by dr r unit vector plus r d theta by dr theta unit vector bracket close multiplied by dr. Okay. Similarly, this vector if I take, then in the position vector of the polar coordinate, we have to take out theta. Then the position vector is r unit vector plus r theta theta unit vector. If I take out theta, it will become dr by d theta r unit vector plus r d theta by d theta theta unit vector bracket close into d theta. Okay, then it now I have to take cross product of this two vectors. The first vector is dr by dr r unit vector plus r d theta by dr theta unit vector bracket close dr cross product dr by d theta r unit vector plus r d theta by d theta theta unit vector bracket close into into d theta. If I settle it down, it becomes dp by dr makes what is P? P is r unit vector plus r theta theta unit vector. dp by dr r is dr by dr r unit vector plus r d theta by dr theta unit vector. dp by dr cross dp by d theta bracket close d theta dr. d theta dr, just leave it. What is dp by d theta cross dp by dr? If we watch closely, P is a point on a line and P is a point on a line. If I combine this, then it becomes dP by d theta r. dP by d theta, this is an abstract notation. dP by d theta r, where P is a area and d of theta r is an area. If I combine two independent components, two vertices, two axes, multiply, it will make an area dp by d theta r. D theta r, theta r means area. dp by d theta r means if there is one unit of area change, if there is one unit of area change in theta r plane, brings how many unit of area change in p position vector. Okay, means if this is the if I'm taking this ith section, if this is position vector, then this is the this is the if this is point p, this is point p, that is r comma r theta. This is the one length vector and this is another length vector on point p only. dp by d theta r. Okay, if I make one unit of change in theta r, how many unit of change I see in the position vector as an area? So this position vector from here to here, it will change, it will form an area. Connect one point to another point, this point and this point. Okay, make a 90-degree angle, makes sense? Take this point and this point. Okay, consider this is a diagonal. Then there will be a line like this and this up. Take this point and this point as a diagonal. How it will draw? Someone will draw triangle. Then it will be base and vertical. It will make a triangle. Half of the rectangle. So there is area with the 2 point also. dp by d theta r means one unit of change in theta r plane brings how many unit of area change in position vector p. If I know that, then how much is the area of this? If I know change in area per unit change in theta r, then if I know y by x, how many dy by dx per unit change in x brings how many unit change in y? If I multiply it by delta x, dy by dx into delta x, then how much will be y if it is delta x? Makes sense? No? Okay, I'll try again. Okay, consider there is a amount called 20 and there is a amount called 4. There are 20 tamarind and 4 oranges. Per orange, there is 5 tamarind. That is 20 by 4, right? 20 by 4. What is 20? Number of tamarind in a bag is 20 and number of orange in a bag is 4. Then per orange, there are 5 tamarind. If that is the case, then if this is the one time scenario. In a bag of tamarind, there are 20 tamarind. In a bag of orange, there are 4 orange. Per orange, there are 5 tamarind. If that is the case, then if orange bag has 10 oranges, then how many tamarind has tamarind bag? Then it will be 5 into 10. dy by dx into delta x, whatever the x is. Similarly, if I have Per unit change in theta r brings how many unit change in area? If I multiply by the theta r, it will give me the net area at another theta r. This is what we are doing. Okay, we have now the area that is made by length vector, and this length vector is dp by d theta r, okay, into delta r. dp by d theta r is per unit change in theta r brings how many unit of change in area made by this point P. If I know this rate of change, if I multiply by delta r, for that delta r, how much will be area it make? That I know. What is delta r? Delta theta is the delta theta of the ith section. And delta r means if r has changed, there may be chance where radius will change with the angle, the way we gave example r equal to cos theta. In that fashion, this radius r1 minus r2 is delta r of the ith section, and this radius is making theta angle with the x-axis. This angle is delta theta I. If I multiply dp by d theta r with delta theta I, delta ri, it gives the area of the ith section. Okay, this is what we have seen. So summation of I equal to 1 to n dp by d theta r, okay, it will come as a vector. Its magnitude into delta theta I, delta ri will give the area of the ith section summation. It will give the full area. Someone has to calculate. We have calculated it many times. Please watch our previous video. Okay, then we tried in same fashion to calculate the for the x and y. What we tried for the x and y? Now we took the length vector. Length vector, instead of taking as r and theta, we took this point as x comma y. This length vector will be I. This length, consider this is arc. Then arc length vector, consider I am taking as I plus the position vector for the point P, that is x comma y, is xi plus yj. Okay, to represent to get the length vector for a curved line, I have to take out independent components. Okay, now two independent components I have to take out. If I want area, one independent component is, if I take, I'm sorry, if I take this line as one length vector and this line as another length vector, if I try to cross it, then I'll get the area. This is what we had started discussion into. This length vector is xi plus yj. Consider, and this length vector is xi plus yj again. For this curve vector, I take out x. It becomes I plus dy by dxj, bracket closed into dx. If I take out y here, then it will become dx by dy I plus j, bracket closed into dy. And actually it is xi plus yj. I take out y. It becomes xy plus j, bracket closed into y. Dx by dy plus j, bracket closed dy. Now the area is I plus dy by dx, bracket close, dx, cross product dx by dy I plus j, bracket close, dy, provided dx and dy both are independent to each other, and that is not the case. Dx and dy are not independent of each other. Okay, if I take xy plane and draw a circle, then y is dependent upon x. I cannot take area as if this is the ith section we are talking, then I cannot take area one as dy and one is dx, making dx and dy are independent to each other. Then how you took r and theta? R and theta we took because r and theta are different coordinate system altogether. This is r theta coordinate system, that is polar coordinate system. This is xy coordinate system, that is Cartesian coordinate system. If I see x is function over r and theta, that is r cos theta. If I see y, that is function over r and theta, r sine theta. In that fashion, in xy coordinate system, if I try to represent, if I try to draw with the r and theta, then it becomes a independent component. R and theta are independent component and dependent are x and y. Since an r and theta, they are independent component in xy plane, we can go with dr and d theta, but in xy plane we cannot go with dx and dy, considering dx and dy independent to each other, because they are not independent to each other. So we cannot proceed with the length vector cross in dx dy in xy plane. One solution is, if this is r theta plane, in r theta plane, this is xy plane, this is xy plane, this is xy plane. Okay, and this is r theta plane. If this is xy plane, this is r theta plane. What is the mapping of xy plane into r theta plane? Now I am draw the reverse thing. In this fashion, xy are independent component and r and theta are dependent component. Okay, then if I try to find area here with the cross product of two vector in x and y, it will work because x and y are independent component, theta and r are dependent component. What is the formula? R equal to a square root of x square plus y square. R is dependent upon x and y. And theta equal to tan inverse y by x. Theta is dependent upon y and x. In that fashion, x, and this is purely research based. This is in dream also no one can find this in any of the book. Okay, then in that fashion, we have now in r theta plane, we have drawing xy. What would be xy here? Y equal to r cos theta, y equal to r sin theta. It will form a sinusoidal wave. Like r theta, if I draw in xy plane, and in r theta plane, it is a rectangle. Consider there is a shape called rectangle in r theta plane. If I draw rectangle in xy plane with the relationship x equal to r cos theta, y equal to r sin theta, in that fashion, if this is x and for some entity r cos theta, this should become x, then that will be hypotenuse. If I have a hypotenuse and angle theta, then r cos theta will be x, r sin theta will be like this. R square equal to x square plus y square. This forms a circle. More or less, it will form a circle if there is a rectangle here with r constant and theta variable. Similarly, if I have a circle in xy plane, if I have a circle in xy plane and I draw that circle in r theta plane with xy variable. Okay, not r theta variable, xy variable. Then x equal to r cos theta. Then it will make a cosine wave. Y equal to r sin theta. If I try to draw any graph here where y equal to r sin theta, y equal to r sin theta, then it will draw a graph like this, something like that. Okay, whatever it is. If I'm able to get the length vector in r theta plane with the x and y independent component, and then I do dp by dx cross dp by dy, magnitude dx dy, and then integration, that will finally result or summation of I equal to 1 to n, and then dp by dx cross dp by dy or dp by dxy, magnitude delta xi delta yi, summation, which will finally result into integration and magnitude of dp by dx cross dp by dy dx dy. Probably we will get in the r theta plane the kind of the area of a circle. Okay, so actually I was thinking a little bit. I'll try more on it. What is dp by dx? P is r unit vector plus theta theta unit vector, not r theta theta unit vector, because we are in r theta coordinate system. Then each point is r comma theta, not r comma r theta, because r comma r theta is a point in xy plane only. These are miniature in mathematics. dp by dx, p is r unit vector plus theta theta unit vector, where r is the square root of x square plus y square. Theta is tan inverse y by x, means a vector square root of x square plus y square, r unit vector, plus tan inverse y by x theta unit vector. For that vector, dp by dx cross dp by dy, it will result into a vector. Calculate the magnitude, then dx dy. Place the integration. Okay, x equal to minus a to a and y equal to, someone can try minus a to a or minus a square root of a square minus x square to square root of a square minus x square. Since it is not available, I'll try it anyway. What is the other solution that we plan to bring it in here? What is the other solution that is the plan? The other solution that is the plan, we have to find a solution where x and y are independent to each other. Then only we can calculate area. If I calculate area in x and y, or sorry, in dx and dy, if I'm trying to calculate area with dx and dy, then in that way dx and dy must be independent to each other. If dx and dy is independent to each other, third party has to arrive now. Then only third party will be dependent on x and y, and x, y will be independent to each other. If I mesh in x and y only, and saying they are independent to each other. So I have to bring either a second coordinate system. If this is the x, y is the coordinate system, then I have to bring r theta coordinate system. And I have to manipulate x and y in r theta coordinate system, claiming r and theta are dependent upon x and y. And x and y are independent. In this fashion, in r theta plane, if I do computation of x and y, then probably I'll get the area. Or in xy plane, if I do computation for r and theta, claiming r and theta are independent and x and y are dependent upon them, then in r and theta, we will get the area. Or if this is xy plane, in this xy plane, now I tilt it like this is xy plane. If I go a third party here called z, function over x and y, and if I manipulate something in z axis, where xy plane is independent and z axis is dependent upon xy plane. Somehow, I have to bring a function that will be dependent upon x and y, and I have to do manipulation in that function, keeping x, y as independent component. In that fashion, it is possible. How it is? Okay. Now we will take a 3D shape. What is 3D shape? Take any 3D shape. Okay, I'll take a sphere as a 3D shape. Okay, later we will see that it will be solved by a cylinder. Let's take a sphere as a 3D shape. Okay, dry one is there inside. Okay, let's take a sphere as a 3D shape. This is a sphere as a 3D shape. This sphere is centered at the origin. The center of this sphere is the origin, 0, 0, 0. Now this is xy plane that is cutting it at the middle. Top is the top hemisphere, bottom is the bottom hemisphere. The center of this, that is this, it go inside and coincide with the origin that is center of this, that is 0, 0, 0. Now at any point, okay, this is xy plane. If this is xy plane, then this sphere is cutting the xy plane at the center. Okay, blue color, middle blue color is the origin. It is cutting it at the center. If it is cutting it at the center, then if I draw the intersection of this sphere on xy plane, it will form a circle. Understand? If I draw the intersection on this xy plane of this 3D shape, it will form a circle. Anyway, now if I talk about the height, if I talk about the height of this sphere, any point, if I talk about the height of this sphere at any point, it is function. If this is the point and this is the xy plane, what is this height? This point. This point is x comma y comma z. Just draw a vertical line in the xy plane. That point will be x comma y. If there is a point P like this, which has a height z, from P, draw a vertical line that will hit the xy plane. That point will be x comma y. So this point is x comma y comma z. Function over x comma y. There is any Python function which accepts x and y as an argument and returns the z, that is the height. Function over x comma y gives the height. Makes sense? Now, if this is the height, now this point P, now I draw a circle like this, keeping y as constant. This is x-axis, this is y-axis, this is z-axis. At point P, I draw a circle like this full, where y is constant in xz plane. At point P, I draw a circle like this, keeping x as constant in yz plane. Now I have two circles. Okay, I have two circles now. This is point P that we are talking on the sphere. One circle is in xz plane, y is constant. Another circle is in yz plane, x is constant. At this point, this is a line. At this point, same point, this is another line. If I do cross, this is the line, this is the line and this is another line. If I do cross product of these two lines, if I do cross product of these two lines at point P, that is the middle point, then we can try to find area of the ith section. Because area we are trying to calculate in the in the circle, not on the 3D shape. Why you are going that much high? I just want area here. And this area I divided into n part. And the ith part, and ith part is this part. I want ith part area. So that summation I equal to 1 to n area of the ith part I have to calculate. But for that only we are doing this, this much. Okay. Now, if I have taken point P in 3D, then this is one line. This is one line. And then this is one line. If I calculate the cross product of these two, then I get the surface area. Then I get the surface area. Means if I take a length vector like this, and if I take length vector like this, or this is the point, this is the point P. I take length vector like this, and then I take length vector like this. If I do cross product of these two vectors, then I get the area of the surface at point P. What is length vector in xz plane? What is length vector in yz plane? If I see xz plane, then there is a arc where y is constant. If I take any point P, P can be described as xi plus yj plus zk. Xi plus yj plus zk, where y is constant, whatever it is. Now, this is the vector that is xi plus yj plus zk. There is another vector that is again xi plus yj plus zk. These are not length vector, these are position vector. To get the length vector, I have to take out one independent component. Okay, I'll take from one, I'll take out x as independent component. From other, I'll take out y as independent component. And both are independent here because dependent is z and x, y are independent plane. Z is dependent. Now I can take. So first vector, if I take x as independent, because if I am xz plane, then x is varying. Along x axis, x is varying. With x, z is varying. This is z, where y is constant. In that fashion, this length vector would become I plus dy by I plus y by x j plus z by x k, I plus dy by dx j plus dy dz by dx k, bracket close into x into dx, where dy by dx is 0 because y is constant. Okay, in that fashion, it will become I plus dy by dx j plus dz by dx k, bracket close into dx. Cross product, another I have to take out y. It will become dx by dyi plus j plus dz by dy k outside dy. Here dy by dx is 0. I'm sorry, dx by dy is 0 because x is constant, whatever. It came as dp by dx, dp by dx into dx cross dp by dy. dp by dx is how much? If p is xi plus yj plus zk, dp by dx is I plus dy by dxj plus dz by dxk. dp by dx cross dp by dy. Just keep in a bracket into dx dy. This is the area at any point P if I take cross product of two length vector. Okay, dp by dx cross dp by dy. That is dp by dxy. If there is 1 unit of area change, if there is 1 unit of area change in xy, then that much unit of area change I see in P. Makes sense? If there is a point here, if there is a point here P, and P go vertically on the xy plane and it hits xy plane somewhere, it hits xy plane somewhere here. If there is 1 unit of area change I make around xy, 1 unit of area change, then how many unit of area change I see in P? P will also change with the xy change. P will also make an area. How much area I see P is forming if there is 1 unit of area change in xy plane? dp by dx. If that is the case, then how many unit of area it will form if there is a delta xi change in x axis and delta yi, that is ith section and jth section get off. If this is this is a circle, this is a circle and this is the ith section we are talking. Okay, if we are talking about the ith section when we started our idea, then in ith section we have, we in ith section, if I talk like this, Radius can decrease also. It's not a radius may be constant, whatever. If radius decreases also, if this is x-axis, then there is delta x change in the x-axis and delta y change in the y-axis. Okay, in that fashion, this delta y, I can say delta y of the ith section and delta x of the ith section. Now, the dp by dxy is the area change on the surface of the sphere IC per unit change in xy. If there is a unit change in xy is delta xi and delta yi, then how much change in p I can see? Okay, that will be the area around PIC when there is delta xi change in x-axis and delta yi change in y-axis. Okay, but boss, we are talking about if there is a delta x, there is if there is a delta x change along x-axis and delta y change along y-axis, we want area of this in xy plane air ith section, not on your sphere. Okay, understood. But on the sphere, if I want the area around P, when there is a delta xi change and delta yi change, that will be dp by dxy into delta xi delta yi. Makes sense? Now, instead of a sphere, consider it is a cylinder. These are not available in any of the book. Anyone can try. I am not hiding anything. Now, consider there is a cylinder. Instead of a sphere, there is a cylinder. Now, can someone proceed? I believe we will try in another session. Okay, can someone proceed now? Instead of a sphere, let's take cylinder. And cylinder is kept at the xy plane. On xy plane, there is a circle. The circle we are talking for which we are trying to get the area, and we divided the circle into n different parts. And the area is summation I equal to 1 to n area of the ith section. Area of the ith section only we are trying to calculate. Area of the ith section makes delta xi and delta yi on the xy plane. That circle, on top of that circle, I made kept one cylinder. Cylinder has top circle as same as bottom circle. Now take point P on the top circle anywhere. Okay, then if I say same expression, point P, now I cut in xz plane, I cut in yz plane. It forms a very peculiar shape on the xz, in the xz plane and in the yz plane. At point P, if I try to calculate the cross product of these two length vector, it will come same as like this: dp by dx cross dp by dy dx dy, or it can be rewritten as dp by dxy bracket delta xi delta yi. Now solve the dp by dxy and then delta x delta y, that is the area of the ith section around P, where P is on the top. On the sphere, P was somewhere on the slant height, but if it is cylinder, then P is on the top, where P is on the circle, that is that circle is same as bottom circle. If I get the area of top circle, then I get the area of bottom circle also, because that is cylinder. More or less, we get the area only of the circle of the bottom. To get the circle of the bottom, we are trying to get circle at the top where P point is there, and dp by dxy is the change in area I get with the 1 unit change in area on the xy plane delta x delta y. If I multiply it by delta xi delta yi, I get the ith section area. If I cut this top circle into n part and I, that will be same as bottom. So more or less we are getting ith section. We will proceed on. It is very, I am badly sweating. This is really kind of something. If someone is thorough in it, then he can crack anything in artificial intelligence. I am 100% sure about it, because there also this kind of only the miniature work will be there, where minute thing will change it, and that will change the result heavily. That we will see. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code. I'm badly sweating. Anyway, please do support us.